Okay, when we're studying momentum, we have to remember that the equation for momentum is P is equal to mass times velocity. So when you're looking at your answer choices here, it says the amount of momentum an object has depends upon, and this says its height from the ground. That's potential energy, so we're not going to use that. Mass and height from the ground. That's also potential energy, so that we're not going to be using that. Only speed. Velocity is your speed with direction, so it's not only speed, and it's not only mass. So hopefully that makes sense to you that the answer would be mass and speed. So when you're looking at mass and speed, the bigger an object is, the more momentum it has. And the bigger the velocity is, the more momentum it has. Okay, so we have to make sure that we're understanding that. Momentum is directly derived from objects moving. So please make sure you write down your notes and you make a note to yourself that if an object is not moving here, if it's not moving, then there is no momentum. Okay. Typically, whenever we look at changes in momentum, we would have a mass that is the same but have different velocities. So that changes the momentum. And that's from collisions or whatever force is being applied to that mass. To then have it have, or if there's not a force being applied, it has motion. So innate in that motion gives a momentum. A good way to look at it is mass gives inertia. So the more mass you have, the more inertia you have, and really it's inertial mass, so it tells you how much you're going to resist the change in motion, whereas, that down real quick, mass equals inertia, whereas motion or velocity will give momentum. Okay. All right, so when we're looking at impulse is force times time. That's impulse. And the impulse theorem says the change in force over time, or a force applied through a given time, is going to give your momentum, or your change in your momentum. So in this case, when we're looking at a golf ball of a mass of m, it hits by a golf club so that the ball leaves the tee with a speed of v. It started at its 0, so now we're just basically solving for that new momentum, and that'll give us what our impulse is. To figure out what the force that was applied to that golf ball, we need to use the average, the impulse equation, and so we're going to basically divide time. They're using a capital T for time instead of delta T, so in this case they're using capital T, and so we can plug that in for that guy. So we would have force times time is equal to mass times velocity. If we want to solve for the force, then we're going to divide by time. Goes away on that side, so then we will have force is equal to your mass divided by your velocity. Your mass times your velocity divided by the time. Okay? Now, so that should kind of help you what relationship we need to find, and it looks like that's your guy. All right? So now, the next thing we need to talk about is what all this means. You apply a force to an object to change its momentum. In this case, the golf ball's momentum was 0 because it was on a tee. It was not moving. Its velocity was 0, so its momentum was 0. You apply a force to it in a given time. That force times the time applied will directly tell you what your new momentum is. Because you have a mass and you're required a force to accelerate it and give it a velocity, you will then have momentum. Okay, so that's where this guy is going to come in. So we want to know what the new momentum is. The force applied to give it that momentum in this case. So that's why we rearranged to solve here. But then the new momentum divided by how much time you applied that force will tell you, determine the amount of force that was given.